No, you didn't.
I didn't?
That could mean that you still didn't.
Yeah.
Okay, so we are going to talk about powers and roots today. Powers and roots. No, more than 2, Sudie.
No, like for my whole grade.
Oh. Oh, no. Okay, well, I don't have time to fix it right now. My stuff got all off, but this is supposed to be a theta, and this is supposed to be a theta. It didn't transfer over very well. Okay, so we're going to do something together. Let's just not write it down. How about that? I'll save us some time. But just do this with me. If z is r cosine theta plus I sine theta, let's talk about z squared. Z squared is just z times z, correct? Okay, and when we multiply the r values, correct? So we would have r times r. And what do we do with the angles? Add them, so we would have theta times theta. Okay, because we're multiplying z to itself, right? Okay. Z cubed. Do you agree that z cubed is the same thing as z times z squared? Okay, so if we take this and multiply it here, when we multiply the r values, what would we get? Okay, and when we add our angles, what would we get? Okay, without following the multiplication rules, what do you think z to the fourth is going to be? Okay, thank you, Monique. Powers are like repeated multiplication. So if we keep following the rules of multiplication, we will get this same rule over and over and over and over. Okay? This is what we call de Moivre's theorem. De Moivre.
Sounds like
Okay, so if we have a trig complex number, they didn't transfer over in this file, so but I don't have time to fix them right now.
Yeah, that's okay.
Okay, so if we have a complex number that is raised to the power of n, then what happens is r gets that power, and then the angle gets multiplied by that power. This in red is probably what you want to write down. Who takes, am I saying that right? De Moivre. Right?
Never say the last one.
It's de Moivre. Okay? So this is de Moivre's theorem. When they say use de Moivre's theorem, this is what you use. Okay? Just write it down.
Spanish 2.
Okay? Also keep in mind whether you want to write this down again or not, but if you're leaving it in trig form, you better reduce that angle to be less than 360. Okay? Don't you think you're going to get some pretty big angles if you're taking that angle times a number? Okay?
Yes.
Before we were just adding two angles together, now we're multiplying by a number. So if your angle is 300 degrees and your power is 5, okay, you have an angle of 1500 degrees, you're going to have to keep subtracting out. Okay? Okay, so I'm going to have a problem on the next slide, and I want us to first think about how we would do this before we knew about trig complex numbers. Are you ready?
Yes.
But I don't want to do this one. I want to do radical 3 minus I to the 10th. So, before we knew about complex numbers, don't write this down with me, but we would have to take radical 3 minus I times radical 3 minus I times radical 3 minus I. How many times?
Yes.
That's a lot of foiling, simplifying. That's too much. Do you agree?
Yes.
Okay, so really, no matter how much work this is, it's going to be better than foiling 9 times. So what we can do is we can take this and we can put it into trigonometric form. So let's do this. The R value, the square root of A squared plus B squared would be, what did you say, Braden? 2. And some of you can see that without doing the Pythagorean theorem, and that is fine. Okay. We also need our angle. So the tangent of theta is -1 over radical 3. Lucky for you, you do have a calculator in your hand. So if you forget your unit circle momentarily, this will give you the reference angle. Our reference angle is 30. Okay. Which quadrant is radical 3 minus I fall? The fourth. So if our reference angle is 30 degrees, then our angle is really 330 degrees. Okay. So what we have is 2. I'm going to use the shorthand. 330 degrees to the 10th power. Are you okay if I use the shorthand?
Yes.
Yes.
I like the short.
Amen.
Good. Very pretty.
Why? Let's write
All right, so now using de Moivre's theorem, what we get to do is we get to take the R value and take it to the 10th power, and we get to take our angle and multiply it by the power. So what we have, I don't know what happened there.
330, not 333.
Thank you, Randy.
What we have, what is 2 to the 10th? 1,024. You know what? I should know that. That was a, we had a math competition where we were tied with Creighton Prep, and it was like sudden death. And the question was, with no calculator, what is 2 to the 10th power? And they buzzed in, and they knew it.
They won.
They won. They won because I know 2 to the 10th on the top of their head. Okay, and so then this is 3,300. Okay, so first of all, I would like you to take 330 times 10 and subtract 360 degrees until you have an angle that is in the first rotation of the unit circle. It's 60?
Yes.
Nice.
Is there like an easier way to do that, or do you just gotta keep subtracting?
Yeah, you just keep
Estimate.
subtracting. Now, you know that it's going to be more than a couple rotations. So if you want to subtract 360 times 3, and so you don't have to keep pressing it, you can kind of gauge that. So this would be the trigonometric form. But if I'm being honest, if I give you a number in standard form, how do you think the answer should be? In standard form. So the cosine of 60 is 1/2. So this would become 1/2 times 1024 would be,
Jeez.
plus the sine of 60 is radical 3 over 2. So we have 512 radical 3. Okay? Which is way better than foiling with complex numbers.
So you would have gotten that if you.
Oh,
Yes.
Oh.
I know. And on top of that, your foiling involves an irrational number,
Yeah.
right? Like,
Ew.
okay. All right. So, half of your homework, I don't think your homework's very long because you have 2 types of problems. This is one type of problem, okay? Take your complex number, put it in trig form, use de Moivre's theorem, change it back, okay? I promise you there will be a problem like this on your test. I promise. I also promise you that there will be a problem like this on your test. Okay? So, before you freak out, okay? I want to talk about roots. So if I ask you for the square root of 4, it is, okay. And why is 2 a second root of 4? Because when you square it, you get 4. Okay? There are, okay, let's talk about 8. What is the cubed root of 8? 2. What if I told you that there are actually 3 cubed roots of 8?
For real?
There are 3 numbers that when you take to the third power, they equal 8. One of them you know is 2, but the other 2 are complex. Okay. For any number, there are exactly n nth roots. So if I am asking you for fifth roots, there are 5 of them. If I'm asking you for square roots, there are 2 of them. If I'm asking you for fourth roots, there are 4 of them. Okay? You've never really known this because we haven't really gone in depth with complex numbers. But for any root that I ask you, there are that many numbers raised to the power to get back. So if I'm asking you for fourth roots, there are 4 numbers that when you take to the 4th power, get back to that original number. Okay? Most of them are going to be complex, which is why we haven't talked about them. To find them, this is our formula. So just write it down and then we're going to talk through it. Okay? This will be written on your test for you. Oh my God. You just have to know how to use it. Okay? Good. I think you have enough to remember with everything else. Law of sines, law of cosines,
Oh, right.
vectors, and this.
love signs.
I thought that there was like the, what's it called?
After
Did we have like a break?
Yeah, was there like a
Spring break.
spring?
break.
Oh, right.
Because we did love signs, love cosines, then we had spring break.
Oh, right.
Yeah.
Wait, what was that chapter that we had on the, I don't even remember. This is kind of complicated.
Okay, so what is going to happen? Here is our trigonometric complex number, and it has n nth roots. So depending on how many roots I ask you to find, if I ask you for the second roots, n is 2. If I ask you for the 10th roots, n is 10. I won't ask you for the 10th roots because that makes sense. Okay? But if I ask you to find the cubed roots, then you're gonna find 3 of these. Okay? You're going to plug 3 in for n. You're gonna start with k is 0. Your next one you're gonna plug in k is 1. Your next one you're gonna plug in k is 2. And you're gonna go until you have enough. You can see like this n minus 1, but what I'll just tell you to do, keep plugging in the next k until you have enough roots. If I ask you for third roots, you have 3 answers. If I ask you for fifth roots, you have 5 answers. Okay? Notice how this says theta plus 2 pi k. 2 pi is the same as what? 360. So if you're going to use degrees, you can just use this as a 360 instead of a 2 pi, and that is fine. Okay? What is going to happen is when you look at our unit circle, whether they're unit circle angles or special angles or not, our roots get spread out evenly across one rotation of the unit circle. So if there are 5 roots and they're all graphed, it'll look like a pizza pie with 5 lines. Okay? If there's 4 roots, they're all going to be 90 degrees apart. If there are 2 roots, they're going to be 180 degrees apart. So you're going to see some symmetry when you do this. Okay? Because of this, all of your roots will be evenly spaced across 360 degrees. Okay? Whether you see symmetry or not, really this is about plugging and chugging. Okay? So if you can plug into a formula, you're going to be fine. But if you don't practice this, you're not going to be fine. So we're going to do at least 1.5 examples. Okay? So we want to find the square roots of this number. And I've given it to you in trig form just as our first example so that we can keep it in what we can see what we need to do here. There. Square roots means we're going to have how many answers? 2. There are 2 square roots. It's the number 2. Okay? So we are going to, first of all, since it's square roots, we're talking about n is 2. We always start off with k equals 0. So if we use this formula, we're talking about the square root of r. R is 16. Then we're going to go to this right here. We have 60 degrees plus, instead of 2 pi k, I'm going to write 360k over n. Okay, well our angle has to be consistent, right? So instead of writing it again, what is 60 plus 360 divided by 2? I'm sorry. What is 60 plus 360 times 0 divided by 2? So what we really have is 4 times the cosine of 30 plus I times the sine of 30. So our complex number is 2 radical 3 plus 2i. Since we need 2 answers, then we need another one, so we'll move to k equals 1. When we do that, this all stays the same, except we need 360 times 1 divided by 2. Okay, Max, now what is it?
Now it's 2.
Now it's 2. So we really have 4 times the cosine of 210 plus I times the sine of 210, which gives us negative 2 radical 3 minus 2i. Remember, I did tell you you were going to see some symmetry. If we were to plot both of these complex numbers, we would see that they are 180 degrees apart. 30 to 210 is 180 degrees apart. Since there's 2 roots, they're going to be splitting that 360 degree difference. Okay. I gave you that number, right, in trig form. Let's talk about a number that's not in trig form. Yes?
So when there's 2 roots, when we find the first one, can we just negate both answers to get the other answer? Like we just made it negative. Can we just do that?
Well, what I would prefer to see is you think of the fact that they're 180 degrees apart and add 180 degrees. Like write this as 210, 210, and then go from there. But yes, that is what is going to happen. Okay. We're going to find the 6th roots of 1. Now, there's 9 minutes left in class. Whether we get all 6 done before the bell rings or not, we'll see. But we'll at least talk about them. Now, you know 2 of the 6th roots of 1. A number to the 6th power equals 1. 1 and negative 1. But there are 4 additional complex numbers that when you take them to the 6th power, they equal 1. So that's what we want to find. Okay? So let's put 1 into trig form. Well, we know the absolute value is 1. What would our angle be? In the complex plane, here is 1. What would our angle be?
0.
Okay. Our complex number would then be 1 CIS. I would use 0, so then your math is easier. Okay. So, we will start with k equals 0. Since we're finding the 6th roots, we know n equals 6. So when we apply this formula, we need to write the 6th root of r times the cosine of our angle plus 360 times k over 6. If you want to do this in radians, you can, but we're kind of in the degree rhythm. So what is our angle? It's 0, isn't it? Okay. So we have the square root of 1 times the cosine of 0 plus I times the sine of 0. That's what's going to get us 1. We knew that was going to be an answer. Okay? You should be excited. We knew that's a sixth root. Now we're going to move on to k equals 1. So we're going to copy paste this formula, except we have 360 times 1. Which means our angle is what for this root? 60 degrees? Okay. So we have the sixth root of 1 times the cosine of 60 degrees plus I times the sine of 60 degrees. If you take 1/2 plus radical 3 over 2i and you raise it to the 6th power, we will get 1. Okay? Now, how many of you find yourself getting annoyed having to write this formula over and over and over again? Okay? Did I tell you that there's going to be symmetry? There is going to be symmetry. How far apart are these angles?
60 degrees.
60 degrees. So that means when we go to k equals 2, this is also going to be 60 degrees apart. So at k equals 2, instead of plugging into the formula, we just know it's going to be 120 degrees. Okay? So we would get negative 1/2, no, yes, plus radical 3 over 2i. Okay? And then we would know that at k equals 3, our angle would be 180 because that's another 60 degrees. The cosine of 180 is negative 1, and the sine of 180 is 0. Hey, there's our negative 1 that we knew we would find. We have 4 roots, right? We only have 2 more. Okay? So 60 more degrees because we're following our symmetry. We're at 240, right? Wait. Oh. And at k equals 5, 60 degrees more, we would be at 300. Okay, so our last 2 roots would be negative radical, negative 1/2 minus radical 3 over 2i and positive 1/2 minus radical 3 over 2i. Okay, this one was nice because we had unit circle values. That's not always going to happen. So if you have an angle like 200, you're going to have to use your calculator and approximate with some decimals. That is fine. Okay? But I wanted to do one where you could know a couple of the answers. We knew 1 and negative 1 would be in there. But who knew that there were 4 more numbers that you could raise to the 6th power to get 1? Okay? Now, we are going to take tomorrow and practice all of this complex number stuff. But if you do not practice de Moivre's theorem and this root formula, come the test on Friday, it is not going to go well for you, okay? So do your homework tonight so you know what questions you have, you know what you need to work on. Okay?
I won't be here tomorrow because I'm going to stay in council.
Yes.
Yes.
So I'm at least going to hand this out.
Okay.
So I'll, if you start on it or not is up to you.
Okay.
But we'll work on it on Thursday.
Oh.
Okay.
Should I